Okay, question 5 to 7, continuing on from the last video. So, onto the blue intermediate questions. It says, question 5, prove that the number of factors of a number is not always even. Okay, and again, if you weren't sure where to start with this, just choose a number and begin with there. So let's just go for the number, I don't know, the number 8. Okay, and let's go and draw a factor bug going all the way back to lower down in our school years. Okay, what are the factors of 8? Well, always 1 times the number itself, so 1 times 8, but also 2 times by 4. Okay, so clearly here, I haven't disproven anything because the number of factors here, 1, 2, 3, 4, it is even. So this one hasn't worked. So you've got to think a little bit outside the box again. And basically with this, you can choose any square number. Okay, so let's just go for the square number of 16. Okay, because right, a square number is always going to have one factor, which is the square root of that number. So for example, 16 is going to be 4 times 4. Okay, but 4 times 4, the only factor there, it is just 4. Okay, it's repeating, but it's one number, which is 4. Which means all the other factors, like the number 1 and the number itself, and any other factors, like 2 and 8, okay, these come in pairs. 2 times 8, one pair. 16 times 1 is another pair. But 4 times 4, okay, it's the only singular one, which means that the number of factors is going to be odd. So basically, right, with this question, you can choose any square number. Okay, so any square number, which we could write, if you want to be fancy about it, something like n squared. Okay, I'm not quite sure what's happening with my pen pad. N squared. So at first, right, we tried something. Okay, unfortunately, it didn't work out. But then I thought, okay, well, that's not going to be working. I tried a square number, and it worked out, which was nice. Okay, good. Question number 6. It says prove that the sum. So I'm looking at adding the sum of 2 irrational numbers. An irrational number is something like pi. It's something that never terminates. You have a non-ending decimal, non-terminating. So prove that the sum of 2 irrational numbers is not always irrational. Okay, so maybe you're thinking at first, well, okay, I'm going to begin with something. So let's just do something like, I don't know, what about pi, add pi? Okay, because these are 2 irrational numbers. What's going on with my pen pad? Sorry about that. These are both irrational. Okay, 3.14, so on and so forth. Add 3.14, so on and so forth. Well, this is equal to 2 pi, okay, which it is still irrational. So this, unfortunately, it hasn't worked. So that wasn't a great start, but it's okay. If at first you don't succeed, you try something else. So this one, let's go for something like this. Okay, thinking a little bit craftily, right? What about if we have a number like this? If we go for something like 10, take away root 2, okay, as my first number. So let's go and call this number the number, no, let's just keep it as that for the time being. Right, this is my first number. This 10 minus root 2, even though I've written it as 2 numbers, okay, 10 take away root 2, you put it on your calculator, you're going to see that you do get an irrational number, which is 8.5857. Okay, but the point is, right, this number here, it is irrational. Okay, I've written it as 2 numbers, but it is effectively one number. Okay, if you simplify it down. So that's good. That's one number. And if I go and add to this number, okay, a second irrational number, because I want 2 irrational numbers. So if I go and add something like, I don't know, root 2, okay, so that's my second irrational number. Well, then what happens here? Well, if you have 10 take away root 2 and you're adding on that root 2, this minus root 2 and the plus root 2 are going to cancel, leaving you with just the number 10, okay, which is rational because it's just an integer. It's not a non-terminating decimal. So there we go, right? I've proven that the sum of 2 irrational numbers, because this number here is irrational and root 2 is definitely irrational. Okay, you can put it into your calculator. Root 2 is equal to 1.414, so plus 1.414. Okay, but the key thing is here, both of these numbers, they are irrational. If I add these together, this with this, okay, the root 2's, they cancel, and I'm left with 10, which is rational. Okay, so how can I write this a little bit more formally? Okay, if I want to be really fancy, I mean, that is plenty, but if you want to be fancy about this, you could say something like, if you do x take away another number like this, and you add on, okay, that number y, where x is a bit like the number 10, which is a rational number. So if x is rational and if y is irrational, okay, like this. So this is just a formal way of representing that any rational number x, it could be 10 I chose here, or it could be the number 20 or 30, okay? And then for any irrational number y, like root 2 or pi or e or anything like that, okay, anything in this format is going to give me a rational number, okay? Because this here, okay, again, the root 2's, they cancelled, and I was left with just that 10, which was good, okay? It proved that this statement is not always irrational. Okay, nice question. Very nice question. And again, this kind of thing, it just comes with practice, okay? It does take a bit of time. Question number 7 says, use a counterexample to disprove the statement. If x is less than 3, okay, this implies, okay, this is consequence. If x is less than 3, this implies that x squared is less than 9. Okay, again, if you weren't sure where to begin, choose an example, but maybe you're starting to spot, okay, I know what I need here. But if you weren't sure, let's just go for a number less than 3, like x being equal to 1, and let's put that in because that is less than 3, which is good. If I put this into my right hand side, okay, so what's x squared? It's going to be 1 squared, okay, which is less than 9. Okay, so 1 is less than 9. Well, unfortunately, that statement is true. 1 is less than 9. I haven't disproven anything yet, but there are many more numbers less than 3. What about your negative numbers? So maybe you're thinking now, okay, right, I'm thinking on the right lines here. Let's go and try a number like, I don't know, x being equal to minus 2. Okay, so what's minus 2 squared? Is that less than 9? Well, minus 2 squared gives you plus 4, but 4 is still less than 9, okay? But you're getting very close with it now. You basically just need a number less than negative 3, and this is going to work. So let's go for x being equal to negative 5. Put it into your statement. Well, what's minus 5 squared? Is that less than 9? Okay, well, it's not, because minus 5 squared is 25, okay, which clearly it is not less than 9. Okay, so, right, basically, any negative value less than negative 3 is going to work. Okay, so this statement down here, okay, has disproven the statement. Okay, when x is equal to negative 5, we've got 25, which clearly is not less than 9. Right, the statement, it just breaks down. I'm going to move this out of the way. It's not true, is it? That statement is not true. Okay, and I think that is it for those questions. We'll get on to the red question and question 9, I believe, also, and that is going to be it for exercise 1C. Thank you.